Physical properties would include color. What is color? It implies presence of other dissolved minerals or materials. Example of these dissolved minerals or materials would be the cationic metals such as calcium, magnesium, iron, and even some of the planktons may also be considered as dissolved minerals. This would be basically unacceptable for aesthetic reasons. Some dissolved minerals would also include the planktons present in the water. This actually is considered because of being unacceptable for aesthetic reason. So for example, if I would tell you to drink a glass of water and it has a color just like of an iced tea, would you drink it? Definitely not, because that means there are there is an indication that the water contains dissolved minerals and materials. There are several sources of color. So you have the following sources. You can have it from the composition of lignin. You can also have it from dye or pulp industry. You can also have it from paper plants. And then the number 4 source would be coming from breweries. It has been found out that the bagasse of the sugar cane that they extract would be containing a certain pollutant called melanoidin. And this melanoidin causes color in water. So there are already current studies being conducted to treat this kind of pollutant. There are 2 kinds of color. So you have the true color and then the apparent color. For color, which is true, it is actually defined as the water upon passing through a filter paper of 0.45 millimeter. And if the water doesn't pass through this filter, it is known to be the apparent color. For turbidity, it implies presence of suspended colloidal solids that scatters and absorbs light. This is actually measured using a turbidimeter. And again, since this refers to the presence of suspended colloidal solids, what is it in us as chemical engineers? It is unacceptable for the following reasons. So you have the aesthetic reason, and then most importantly, the filterability problems. What would happen if you have this high turbidity in a particular industrial plant? There's such thing as fouling that you have learned in fluid mechanics. What would happen if you have fouling? Let's say you have this pipeline and then you have fouling. What do you think would be affected? It would affect the flow of your fluid. And aside from that, since you have fouling, which eventually brings the formation of scales, these scales would serve as a corrosive material that would destroy your pipeline, as well as your equipment. Aside from that, these may also cause formation of biofilms, and this biofilm would be the source of disinfection problems. One of the physical properties would be odor and taste. This is caused by dissolved organics, phenols, chlorophenols, and inorganic chemicals and organisms. This may also be due to decaying microorganisms or algae, or sometimes it is due to high concentration of salts such as calcium +2, Mg +2, and chloride ion. However, this part or this physical property is subjective and it is difficult to measure. The next physical property would be solids. Now, there are several types of solids, insoluble and soluble components of water, and therefore you need to classify. How do you classify? Normally, in wastewater industry, we make use of an Imhoff cone. An Imhoff cone is used to determine the settlable fraction of wastewater. So how would you distinguish an insoluble and soluble components? You make use of these parameters so as for you to determine which is the total solids, the suspended solids, the total dissolved solids, the total volatile solids, and the volatile suspended solids, as well as the settlable solids. This gives you an example how an Imhoff cone works. Each of these fractions would have different filtering mediums with different filtering mesh, so as to distinguish one kind of solid from another. Now, there is a certain computation on how to compute the total solids for a particular water or wastewater. So that is, you have to add the suspended solids with that of the total dissolved solids to get total solids. And then, the rest of the solids will be taken care of using other method of determining its components. For example, the volatile solids will help you determine the total organic carbon. So that is, upon getting the volatile solids from the Imhoff cone, they ignite it at a very, very high temperature, normally in a furnace at 600 degrees Celsius, and then they make use of the atomic absorption spectra to determine the carbon dioxide content. And then you use the gravimetric analysis to compute for the total organic. This is a typical laboratory for a wastewater, determining the different solid particles. The next physical property would be temperature, which is one of the most important, because you have known from your basic chemistry that temperature affects other properties. It increases rate of chemical reaction, and it even affects the solubility of gas. What's the rule of thumb? As the temperature decreases, the solubility of the gas increases. So in this particular case, remember the fish kill. If you have higher dissolved oxygen in the water, that means the temperature is relatively low. But if the temperature is high, due to the occurrence of thermocline or a rapid change in vertical temperature of a lake or a river, that would affect the concentration of dissolved oxygen. Now, the presence of dissolved oxygen would also be affecting the capability of the water to purify itself. So, if the dissolved oxygen is low due to high temperature, the water purifying capability would also be low. The next physical property is conductivity. This is due to dissolved ions in solutions that conducts electricity, and you can measure it using a conductivity apparatus. It is also telling us the measure of the ability of an aqueous solution to carry an electric current. And for a particular water, the standard would be 0.05 microsiemens per centimeter. This unit of measurement is mho, which is actually the opposite of resistance. The last physical property is dissolved oxygen. This tells you the critical requirement of the organism assemblance associated with a diverse and balanced aquatic system. If you recall your laboratory, you have determined the dissolved oxygen, and it's one of the critical parameter of water. What is the minimum, or what is the critical DO concentration? As you recall, it's 5 ppm. If it's already below 5 ppm, it's no longer habitable for organisms. So for example, your Pasig River, what do you think is the dissolved oxygen concentration? You have measured dissolved oxygen in your laboratory using what method? Winkler method, wherein you have determined the DO using different chemicals with an indicator of starch. Chemical properties as water quality can be divided into two. You have organic and inorganic subgroup. For the chemical properties organic, we have the different constituents or components, namely carbohydrates, fats, oils, and grease, pesticides, phenols, proteins, surfactants, volatile organic compounds. For the carbohydrates, fats, oils, and grease, basically this would be coming from the food industry. So the fast food like Jollibee, McDonald's actually have this as one of their problems. So since they don't have their wastewater treatment plant for each branch, what they do is they just implement some trapping of oil and grease as part of their treatment prior to the discharge to the municipal wastewater pipe. Now for pesticides and phenols, these are basically coming from agricultural irrigation, and also phenols may be utilized as one of the solvents in most industries. For proteins, that would also be added to the group of carbohydrates, fats, oils, and grease coming from restaurants and some fast food chains. For surfactants, this would be coming from detergents. So washings coming from residential houses would also contain surfactants, because one of the major components of detergent to add to its cleansing capability would be the surfactants. And then volatile organic compounds may also be utilized as solvents in most of industrial plants. Now, some of the naturally occurring organic substances are classified as this: the proteins, lipids, carbohydrates, plant pigments. While for the synthetic or the anthropogenic sources, that would be coming from pesticides, agrochemicals, the surfactants, and then the halogenated hydrocarbons. Normally, the halogenated hydrocarbons are utilized in bleaching industry. Now, another chemical property under organic would be biochemical oxygen demand, or sometimes called biological oxygen demand, but biochemical oxygen demand would be the most appropriate term being utilized nowadays. This is actually the amount of dissolved oxygen used up by microorganisms to break up organic materials in water at 20 degrees Celsius over a period of 5 days. Now, to simply illustrate this, I normally have this illustration. If you have organic waste, which would comprise of either carbon, or normally comprise of carbon and nitrogen, in order for this organic waste to degrade, what do you need? You would be needing bacteria. So since bacteria lives because of the presence of oxygen, these would be depleting some of the oxygen present in water. So normally, your bodies of water have the corresponding dissolved oxygen. And therefore, this oxygen can be a source for these bacteria. And therefore, we could say that your rivers as well as your lakes have its natural capability of cleansing itself. However, if you would be having high concentration of organic waste, what would be needed would be higher number of bacteria, and therefore this would also entail higher demand for oxygen. And therefore, this would be affecting the concentration of DO, which we learned a while ago in physical property that one of the major critical quality that has to be monitored in a river. So we would relate that this oxygen, which is represented by BOD, to your dissolved oxygen. So again, what's the correlation? The higher your organic loading, represented as L, let's say LO, because it refers to organic waste, the higher BOD you have, and therefore, the lower DO you would have in your bodies of water. So this is how we define this important chemical organic property. Now, this one can be, as mentioned, subdivided into two. Since organic waste may have these components, the carbon and nitrogen, therefore, the theoretical oxygen demand needed to break down this organic waste, represented by THOD, is actually a summation of CBOD, which refers to the carbonaceous oxygen demand, plus the nitrogenous oxygen demand, or represented as NBOD.